Hello guys, welcome back to my YouTube channel Programming Programmer. So today we are going to see a very interesting algorithm called Kadane's algorithm. What it algorithm says us to is it tells us the maximum sum subarray in our array. So let's assume we are having an array called A, and in that array we are having elements like 1, 4, 5, 3, and then 0, then again 1. So let's assume this is the array that we are having. So we need to find the maximum sum subarray from this array, and to find that we can use Kadane's algorithm, as it is an efficient approach to solve this problem. So first of all, let us see what a subarray means. Okay, so subarray means that it is an array within an array. Okay, so array is a contiguous part, so subarray is also contiguous in nature. So let's say what is not a subarray. So 1, 5, 0, like we are having 1, 5, 0. So this is definitely not a subarray. This will come under the category of subset. So what a subarray starting from 1 will be, like it will be 1, 1, 4, 1, 4, 5, 1, 4, 3, and so on. So these all elements like 1 to 1 will also be a subarray. So these all will be considered under category of subarray. So let's see what could be the naive approach to solve this problem. So the brute force approach to solve this problem will be like we need to compute all the subarrays from our array, and after computing all the subarrays, then we will see which subarray is having the maximum sum. Okay, so calculating all the subarrays takes order n square time. So this brute force algorithm will obviously take order of n square time complexity. So let's see how that algorithm will work. So we will iterate over all the elements in our subarray, and then we will iterate over all the elements in our array, and then we will try to find out all the subarrays for that particular element, and that's how we are going to do that. So assuming that we are at 5 at a moment while iterating over it, then what I am going to do is I will calculate all the subarrays that are starting from 5. So it will be only 5, 5, 3, 5, 3, 0, 5, 3, 0, 1. Then what I will do is I will see that which one is the maximum, and if it is maximum, it is greater than the variable that I am storing. Let's say that variable is max sum. If it is greater than that, then I update my max sum. So by this I can find out the maximum sum subarray in order of n square time. Now let us see how to solve this problem more efficiently. So in by using Kadane's algorithm, we can solve this problem in order of n time, in linear time, which is much efficient than order of n square. So how Kadane's algorithm will work? What I am going to do is I am just going to run a for loop from I equal to 0, I is less than n, and then I plus plus. Before running the loop, I am going to take two variables, and let's say the first variable is maximum till here. So I'll abbreviate it, maximum till here, and I'll initialize it to 0. Then let's say my second variable is maximum till maximum in array. Let's say our second variable is maximum in array, so MIA, and I'll say this is also equal to 0. Now what I'm going to do is I'm going to check if so. Before checking, we are going to do one more thing. So while I enter the loop, what I am going to do is I'll increment mth by ARRI. I'll increase the MTH by ARRI. Then what I'm going to do is I'm going to check if MTH is less than 0. If MTH is less than 0, then what I'm going to do is I'll give MTH value of 0. Then after giving the value of 0 to MTH, what I'm going to do, well, what I did till here is I just eliminated the possibility where the MTH, where the maximum till here could contribute to decreasing the value after it. So what I mean by this is, let's assume that we are having our array like 1, 0, then -4, then let's say another element be 129. Okay, so we are having our array like this. Now let's say definitely our maximum sum sub array will be 129. Okay, now my maximum till getting to 129 will be -3. So if I add -3 to 129, then I'll get value less than 129, which will like contribute to reduce the value. Like contribution for the previous maximum till here should be should be towards maximizing, not towards reducing by even a single bit. Okay, so what I will do is when I get -3, then what I will check is if MTH is less than 0. If MTH is less than 0, then I will give MTH value of 0. Then what will happen is I will go to this, then I will again do MTH plus equal to ARI, and it will become 129. So this is what this code segment does. Now going further, I'll check one more condition. If MTH is greater than MIA, MIA is maximum in array, so it is the maximum sub array, it will represent the maximum sum sub array MIA. So I will check if MTH is greater than MIA, then what I am going to do is I am just going to do MIA is equal to MTH. After all this iteration is done, after the for loop is completed, so this is how my for loop will look like. After my for loop is completed, what I am going to do is I am just going to return my MIA. And this will be the maximum sum sub array according to Kadane's algorithm. So we can see that by Kadane's algorithm we can easily find our maximum sum sub array in order and time. I would recommend you should try run some by taking some test case, like you can take this test case, or you can also take this test case, or you can make up a test case randomly, and you should at least try run it once, then it will be crystal clear to you, so you won't forget it later on. So this was all about Kadane's algorithm. Thank you for watching. If you like my content, then do like, subscribe and share this video.